Hello, everyone. My name is Stephanie Stransky. I'm a research fellow in the lab of Simone Sidoli at the Albert Einstein College of Medicine in New York. I am a scientist focused on developing primary and immortalized cell culture models to identify the effects of external agents on cellular metabolism and epigenetics regulation. During my PhD in Brazil, I optimized in vitro cellular models to determine the main toxic activities of snake venoms for reducing the use of experimental animals. And during my sandwich PhD at the Imperial College London, I showed that snake venoms and their toxins trigger cell death pathways on human keratinocytes, which is one of the most affected cells during local envenomation. As a postdoctoral fellow, I established an in vitro system to address antivenom neutralizing potency, which is a mandatory test before antivenom is approved as a snake envenomation therapy. In October 2019, I joined the research group of Dr. Simone Sidoli, and in his lab, I have established an innovative 3D cell culture system that models a similar proliferation rate of and cell-cell communication as primary tissues, avoiding the bias from flat cell culture of rapid DNA replication, and therefore non-physiological chromatin state. This is especially important in aging research, where most aging cells have a long life and have a chromatin state that is usually different from cells that have been rapidly proliferating. My research is now centered on uncovering the molecular mechanisms that drive the progression of aging. And to achieve this, my efforts are directed towards exploring the proteins associated with DNA and chromatin during the gradual decondensation process that follows cellular aging. I am developing mass spectrometry techniques which enable the examination of the proteome attached to the chromatin and the exploration of novel post-translational modifications of histones. I'm using the 3D spheroid culture that I established to simulate aging-related molecular alterations. And this model is crucial for assessing the impacts of anti-aging compounds in the lab setting. I was the first scientist to introduce in the United States the Kleiner reactor system from the Danish company Cell Vivo for culturing cells in 3 dimensions. This 3D culture has been a milestone for our research group, and due to the successful optimization, I'm leading the USA training site of Cell Vivo. My goal is to complete my training by becoming a unique type of scientist who can establish new model systems for different human conditions and characterize them using state-of-the-art proteomics technology. I am confident that this portfolio will allow me to significantly contribute to aging research, where the increase in chromatin entropy is a vastly unexplored issue.